Simultaneous equations. We're going to deal with what simultaneous equations solve for graphically, and we're also going to deal with a couple of methods. We're going to do this for 2 and 3 variables. So let's start with 2 variables. Well, if you were asked to solve the simultaneous equations, what you could do is you could plot the two of those because both of those represent lines. So take an x of 0, 1 and 2, get corresponding y's using substitution, and from that then you've got 3 points for each line. That will allow you to plot the following. And the simultaneous equations, when you solve them, find the point of intersection for the line. So that's where the lines cross. In this case, by inspection, you can see on the graph that the point of intersection is 3, 2. So the solution for the simultaneous equations is 3 and 2. X equals 3, y equals 2. Okay, how you do it with algebra then? So what I would do is I'd put the two equations over each other. And what we want is the same number in front of either the x or the y, but the opposite sign. And if you look, the number in front of the y's is equal to 1 in each case, but there's a plus and a minus, so they have the opposite signs. If that's the case, we can just add and subtract vertically. So plus y minus y, they're gone. And x plus 2x is 3x, and that's equal to 9. Solve then for the x equals 3. So that agrees what we had on the previous slide. And then we sub that x value into either one of the two given equations, and then we can find a y value from that. So x plus y equals 5 is the top equation. We know x equals 3. Bring the plus 3 over, it becomes negative, and y is equal to 2, which is what we found in the previous case. Now basically what we're doing here in the first step, so that's the first column, we're saying that the two lines meet at a particular y value, so we leave them equal to each other at that y value. And if they're equal to each other at a particular y value, we're finding out what x position that occurs at. Once we have that, then we put that x position into either equations and we get what the y value was. Okay, second method. Solve the simultaneous equations. 2x plus y equals 12 and y is equal to 5x minus 2. In this case, we're going to use a substitution method. So the second equation, y is the subject of the equation. So instead of y in the first equation, we're going to put in 5x minus 2. So there are my two equations. Like I said, in the first equation, we'll have 2x plus, instead of y, we'll put in 5x minus 2, and that should equal 12. So the first step there is we've made that substitution. Then it's just a case of simplifying it, making x the subject of the equation, and x works out as 2. Just like with the previous method, to find the y value now, we substitute x equals 2 into either of the two original equations. So the person who did this out put it into both equations just to show you that it doesn't matter what equation you put it into, you will get a y equals 8 irrespective of the equation you select. Okay, a little bit harder now with the substitution method. So we have two equations, 3a plus 2b is equal to 7, 4a minus 3b is equal to 2. So what you want to do is make one of the variables the subject of the equation. In this case, we take equation 2, rearrange it, so bring the minus 3b over, it becomes plus 3b. So we have 2 plus 3b is equal to 4a, and then divide both sides by 4. So a is the subject of that equation. And then what we'll do is instead of a in the first equation, we put in 2 plus 3b all over 4. Now it gives us something a little bit complicated. What you're going to have to do is multiply every term by 4 to get rid of the fraction, or the denominator I should have said, and then simplify and solve for b. And then like the previous examples, to get a value for a, we substitute 22 over 17 into either of the top two original equations. And when you simplify that, you get a is equal to 25 over 17. So it's just a substitution. Okay, you can pause the video here and have a look at simultaneous equations with two variables. Solve it with whichever method you find necessary. All right, simultaneous equations with 3 variables. So instead of just x's and y's now, we have x, y's and z's. Now if we had just x and y's, that would mean we're dealing with lines on an xy plane. If we have x, y's and z's, it means we're no longer dealing with a line on an xy plane. We're dealing with planes in 3 dimensions. So I've got 3 equations there. those could be represented by 3 planes there. So we've got a light green, a light blue, and a peach colour. And the point of intersection for all of those is that black dot in the middle where all 3 planes meet. Now, how would you do it? So I would take the first 2 equations and get rid of one of the variables. So for example, we could get rid of the z. So you would multiply the top line by 3, bottom line by -4, and then when you get rid of the z, you'd be left with an equation of a line. In other words, an equation with just 2 variables. So basically what we're doing there is we're taking plane number 1, which is labelled in red, plane number 2, which is labelled in red as well, and then when you solve the simultaneous equations and get rid of one variable, what you end up getting is the line of intersection between the two. So it's that line there. So that's the line that unites the 2 planes. Then what I would do is I would look at the next 2 equations. So equations 2 and 3. I would get rid of the same variable I did in the first case. So let's say that was z. I'd get rid of the z again. And then I'd have a second equation of a line with x and y in it. When you do that, referring to the diagram, it would find the line of intersection between planes 2 and 3. So something like that. And then all you do is you would solve the simultaneous equations between those 2 lines. So again, the method would be eliminate one variable from equation 1 and 2, eliminate the same variable from 2 and 3, and then your answers in both cases are equations of the line. You would solve the simultaneous equations for the equation of the line, and then you'd be able to get x, sub it in to get y, and then sub x and y into any of the 3 equations there to get your z. Now let's see it being done. Okay. First of all, eliminate one of the variables. In this case, I've decided to eliminate the 2. So multiply the second equation by 2. That gives me 7x plus 10z equals 19. And that's an equation of the line with my 2 variables of x and z. Then I would take the another 2 equations. In this case, I've taken equation 2 and 3. I've multiplied equation 2 by a multiple of 3. And you cancel off the same variable you did in the first case, which was the y value. And that gives me a new equation of a line minus x minus 4z is equal to minus 13. Now I'm going to take the new equation 1 and the new equation 2 and solve the simultaneous equations between the 2 of those. Now when I solve those, I get z is equal to 4. And then what I can do is sub the z equals 4 into either of the 2 circled equations. When I do that, I'll get x equals minus 3. Now, there are 3 variables. There's an x and a y and a z. I have x and z. I need to find y. And the last thing then that you should do is take the x equals minus 3, the z equals 4, and put it into any one of the 3 equations on the left-hand side. So when you sub it in, and I've put it into equation 2, you get y is equal to 2. So the solution is x is equal to minus 3, y is equal to 2, and z is equal to 4, which can be written in coordinates as minus 3, 2, 4. I'm going to not check this in this case. All right, time for method 2. So method 2 is very similar to the substitution method we used with 2 variables. So we'll take an equation, and the first thing you want to do is make one of the variables the subject of the equation. Equation 3 is that done for us already, so z is equal to x plus y. And what I would do is take that x plus y and put it in instead of z in the first and the second equation. And then we'll have 2 equations with just x and y in it. So let's have a look. So what I have is I've taken the top equation, I've rewritten it. So x is equal to 24 minus y minus z. And instead of z, I can put in x plus y. Now I'm going to simplify that. Bring the minus x over. And then I'm going to divide everything by 2. Right? Now what I can do is I can take that x value and put that into equation 2. So I'll have 5x would become 5 bracket 12 minus y. And I also know instead of z that I can put in x plus y instead of the z. So let's take equation 2. Instead of the x, I make my substitution. Instead of the z, I make my substitution. Now, I'm going to then rewrite the x in line 2 as 12 minus y. That's the second bold text in the middle. And then I now have an equation for y. I just need to solve for y. So going through that, the y works out as 8. So I have what y is. Now I need to find what x is. So let me get rid of all of the kind of rough work. What I would do is put the y equals 8 into the second equation. That would give me x equals 4. And then I'd put the x equals 4 and the y equals 8 into the first equation. And that gives me z equals 12. So there are my answers. X equals 4, y equals 8, z equals 12, which can be written as the coordinate 4, 8, 12, as the point of intersection between the three planes.